I'm Joe Montemarano. I'm Executive Director of a National Science Foundation Engineering Research Center on mid-infrared technologies for health and the environment. Basically, we make novel mid-infrared sensor systems that do trace gas measurements. Very precise but cost-effective, on the order of mass spec GC quality, but at a fraction of a cost. Applications are in environment, greenhouse gas measurements, homeland security, and in health. And so in terms of today's BioNJ program, I highlighted a number of medical mid-IR applications that run the gamut from breath-based monitoring diagnostics, glucose monitoring through skin, direct measurement of carbon dioxide and oxygen equivalent of the pulse oximeter in real time, and cancer detection, as well as environmental health applications. And so again, the center works by, first off, we have a number of universities in addition to Princeton University, University of Maryland, City College of New York, Johns Hopkins University, Rice, and Texas A&M are our academic partners. And then we have about 50 members from industry, both small and large companies, as well as the national labs. And so the center does fundamental research, but always in very direct connection and informed by applications. And so very quickly we move from this discovery research into test beds. And so we've been very fortunate in the environmental area to have debuted a system in Beijing before, during, and after the Olympics, and actually were able to answer a question we didn't expect to have to answer, which was why the air quality was as good as it was. And as that has actually allowed us to really increase interest externally in what we're doing, we're now moving our focus into the medical areas because we can very precisely measure chemicals, especially small molecules. We think the opportunities are very abundant in terms of applying this new very cost-effective diagnostic technology to make real differences in the lives of patients. And just in one example, if you think about, with an aging population, currently about $40 billion a year is spent on dialysis. And typically the regimen is the patient goes in 3 times a week, is dialyzed for 2 to 3 hours, whether he needs it or not, basically. And there really isn't any therapeutic level of ammonia, for instance, which is by removing urea during dialysis. We think that, in fact, that's a very accessible breath biomarker for us to use, and that there will be true cost savings, but more importantly, the overall experience will be better for the patient. And I think that that's really where what drives us, is how can we make a difference. And again, as a university, our product is our students, our education, but the students that we are educating are working in teams and collaborating with, again, external companies and with the national labs. And so that we're also very fortunate that some of them are interested in entrepreneurship. And so there is a whole new vector for us to move technologies out into the marketplace by spinning off our students, who in turn are commercializing the technology.